A few minutes. We're not going to learn a lot here, but then I ended the last video by saying sometimes the cycle of remainders goes pretty long. One such case that you need to commit to your memory is 2 raised to n divided by 25. So let's finish it here. Thankfully, the base is 2, so you can go very fast with the cycle of remainders. As n changes from 1, 2, 3, 4, the remainders are 2, 4. Remember, your divisor is 25, so don't let it cross 25. The moment it crosses 25, divide it further. 2, 4, 8, 16, 16 twos are 32. 32 divided by 25 will leave a remainder 7. 7 twos are 14, 14 twos are 28. 28 means a remainder of 3. 3 twos are 6, 6 twos are 12, 12 twos are 24. Remember, 24 is a remainder of minus 1. So we get here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at the 10th power we get minus 1. So at the 20th power, we are going to get a plus 1. But we don't need to continue. So all we can say is the cycle has, the remainders has 20 different possible values. Right? As the cycle will be of 20 different values. Why I say commit this to memory, or let me help you out in your memory is, you know that 2 to the power 10 is 1024, and 1024 when divided by 25, the remainder is going to be minus 1. Why? Because 1025 is a multiple, and just one less than that, remainder is minus 1. And for the moment you get this, just square it up. 2 raised to 10 squared, that is 2 raised to 20 divided by 25, the remainder will be minus 1 squared, that is a plus 1. This is what we did. So I hope this will help you. 1024 is the key word here, right? 1024. The moment I see a 25 and the powers of 2, 1024, it clicks in my mind first, and I don't even write the cycle. I know at 2 raised to 10 it will be minus 1, at 2 raised to 20 it will be plus 1. Then I'll find only that part of the cycle for which it is necessary for the question. And as I was saying, you will find this when you find the last 2 digits. So watch those videos, you'll have a reference for this. This is the appropriate moment to get Euler's theorem into picture. As if Fermat was not enough, there's Euler's also. I'm a big cynic of these. I've been trying to resist in this industry for a long time. Don't learn Fermat, don't learn Euler's, don't teach, it's of no use. Well, Euler's theorem first is a generalization of Fermat's. If you're doing it, do it very well. It follows a similar pattern as of Fermat's. So I'll again make the language more amenable for students. I'll not stick to the textbook language. So it says a certain power of A when divided by the divisor will leave a remainder of 1. Right? The cycle, it will come somewhere we get 1. Would this always be there? Hang on, listen. Which power of D? And the power of D is called the totient function of D. This is your complete Euler's. There is still a condition, and the only condition is now that A and D should be co-prime. Compare it to, this would not be very clear as of now. Hang on. There are a couple of things that I have to. I'll come to this after a few remarks. What was Fermat's? In Fermat, the additional condition was divisor had to be prime. So Fermat's little theorem can only be applied when the divisor is prime, and obviously the dividend, the base has to be co-prime. Here also the dividend and the divisor have to be co-prime, the base as it. but the divisor need not be prime. So when you divide by 25, you cannot apply a Fermat's theorem. 2 raised to 24 is not going to give you a plus 1. You cannot apply a Fermat's theorem because 25 is not a prime number. But can I apply a Euler's theorem? Yes, Euler's theorem. This could be any divisor. Now let's come and understand what is this. This is, in a bigger picture, phi of divisor, phi, P-H-Y. Textbook language we are getting into. It is called the totient function, totient, T, totient function. So obviously these are things which put students off. So by Euler's theorem, all I'll just say is, for any divisor, a raised to the totient number of d will give you the remainder y. Now the obvious question comes down to, what is a totient number? We are going very far away from what we intend to learn. The totient number is finding the number of numbers co-prime to d from 1 to d. From 1 to d or less than d. How many numbers less number of co-prime? Okay, let me rewrite it. It's just that how do I make it suitable for students? That's it. And anyways, I'm not even interested in doing this anyway. So since I started, this is the number of numbers less than d that are co-prime to d. Okay, and how do we find this? You take that number d itself, you multiply it with 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3, and so on, where p1, p2, p3 are the prime factors of d. Now I'm not going to explain this formula, or else we are going to go very far away. So let's quickly see this. 25. Let's find the totient function of 25. Let me do it here. It's a very easy one. Totient function of 25 is 25 into, thankfully, which are the prime factors of 25? Thankfully, 25 is 5 square. There's only one prime which is 5. So this is all that you need to do. This is 4 by 5, 5 5s are, and this is 20. So the totient function of 25 is 20. And as per Euler's, let me write the name again. Let's pay enough respect for him. This says, when you divide a number by 25, if the power is 20, the remainder is going to be 1. Always, no, just one condition, that a and 25 should be co-prime. So is 2 and 25 co-prime? Yes. So dividing by 25, 25 is not a prime, Fermat not applied, totient function of 25 is easy to find. Okay, it's 20. So 2 raised to 20 will give you 1. Does 2 raised to 20 give you 1? Yes, 2 raised to 20 gives you 1. So is it useful?